Hello, welcome to our next section, 7.4. We will be discussing scales today. There are times that when you're looking at a map or a house plan or talking about maybe a model airplane or a model car, we're looking at a scale drawing. Maybe we would be looking at a map. Of course, nowadays we have a GPS on our iPhone or on our smartphones, and we would not have to worry about figuring out the distance from maybe, say, San Francisco to Yosemite. And we wouldn't really have to worry about figuring out the distance because the GPS will tell us automatically. But if you did look at a paper map, which hopefully some of you have seen before, but if you were to look at a paper map and try to calculate the distance from San Francisco to Yosemite, on that paper map you could measure it maybe in inches or centimeters, and each inch or centimeter will represent a certain number of miles, and then we can calculate the distance in miles from San Francisco to Yosemite based on the number of inches on the paper map. That is an example of a scale drawing that we will be discussing. Now, first of all, let's take a look at some proportions. Back to some proportions. It's been a while since we've discussed some of this. But if you take these proportions here, 2 to 7 as 6 to 21, and you rewrite them in fraction form, 2/7 is equal to 6 over 21. What are the extremes? Remember what the extremes mean, meaning the top, the first number, and the last number, those are your extremes in this proportion. 2 and 21. Now, what about the means? The means mean the two numbers that are in the middle, in between those two extremes. And what are those two numbers here? It's 7 and 6. Does the product of the extremes equal the product of the means? That means if I take the extremes 2 and 21, multiply that together, does that equal the means multiplied together, 7 times 6? Now, what's 2 times 21? 42. Now, 7 times 6, yes, it's also 42. So, the product is equal, and the product is 42. Now, let's take another example here. Use the rule for dividing rational numbers to find the quotient. So, here we have a fraction, 2/3, but it's divided by 50. How are we going to solve that? That is the same as saying 2/3 times 1 over 50, because this fraction right here, that is the same as saying 1 times 50. And then so if we cross canceled here, you could factor out a 2 and then divide 50 by 2, and you have 1/3 times 1 over 25. And then that's equal to 1 over 75 for your final answer. Now, we're going to take these two methods of proportions and your fractions, and we will be applying it to our scale drawings and trying to calculate the scale drawings, the actual distance from the scale drawings. A scale for a drawing or a map is the ratio of the drawing's length to the actual length. And a scale drawing is a drawing in which all the lengths are at the same scale or ratio to the actual lengths of the object. So for example, if I'm going to use an inch and represent that, maybe an inch is equal to 10 miles. And if I have the distance from San Francisco to Disneyland, how many inches is that going to be on the map? And then say that is each inch is 10 miles, we can calculate the actual distance from San Francisco to Disneyland. Now, obviously though, I think from San Francisco to Disneyland is going to be a lot more than just 10 miles per inch. We would have to actually calculate that more carefully and have each inch represent a more realistic number of miles. Okay. Now, a scale is a ratio. Ratios are these fractions, right? Where two numbers are compared. So a scale is a ratio. 1 inch to 10 feet is the same as 1 inch to 120 inches, which is equal to 1 over 120, 1 over 120 of the actual size. So this would be your scale, or the ratio of the actual size. Now, let's start looking at a couple of examples here. A drawing of a bridge uses a scale of 1 centimeter to 5 meters. If the actual length of the bridge is 27 meters, how long is it in the drawing? So, we're going to take this proportion, 1 centimeter to 5 meters, and rewrite that as a ratio, or a fraction, or the same as a proportion. Okay, now let B equal the length of the bridge. We have the actual length of the bridge is 27 meters, but we need to find out the length of the bridge according to the drawing. So that's going to be B. Now we're going to set up, here's our proportion, 1 centimeter to 5 meters, right here, 1 to 5. Then B is the length of the bridge in the drawing. So that would be on top. And then the actual length of the bridge is 27 meters. That's going to be on the bottom, because the bottom here, 5, that's your meters. So I have 1 centimeter to B centimeters, and then 5 meters here, and 27 meters here. Then I can cross multiply. 5b is equal to 27, or 27 equals 5b. And then I'm going to have to solve for b. So I would divide 27 divided by 5, and then I get 5.4 centimeters. So the length of the bridge in the drawing is going to be 5.4 centimeters. Our next example, the distance between two towns on a map is 3.6 centimeters. The scale is 2 centimeters to 15 kilometers. What is the actual distance between the towns? So we're going to take our scale right here, 2 centimeters to 15 kilometers, and we're going to set that up. First, we're going to find N be the actual distance between the towns. Okay, that's what we need to find. And then, as I said earlier, our scale, 2 centimeters to 15 kilometers. Here I have 2 to 15. And then what is that equal to? That's equal to the scale here. On the map, the distance between the two towns is 3.6 centimeters. But now we need to find the actual distance between the two towns. And that's going to be on the bottom of the fraction, which is where the 15 kilometers is as well. Also on the bottom of the fraction. So now we can cross multiply 2n, and then when you multiply 3.6 times 15, you get 54. And to get the n by itself, you divide by 2. 54 divided by 2 gives us 27. And so the actual distance between the two towns is 27 kilometers. Now here is an example with an actual map so that you can actually see what we're talking about here. Find the distance between Carville and Danville. Here's Carville and here's Danville. Now, in our scale drawing, Carville to Danville, you could say that's 5 centimeters. And then here's our scale. 2 centimeters is equal to 25 kilometers. So every 2, that's about almost half of this length right here. Okay, so from Carville to maybe about right there, that would be 2 centimeters. And they're saying that those 2 centimeters right here is equal to 25 kilometers. But if Carville to Danville here, this length is 5 centimeters, then we need to figure out what is the distance, the actual distance between Carville to Danville. So here's our scale. 2 over 25, 2 centimeters to 25 kilometers, is equal to 5 centimeters, and then we need to find the actual distance right there. So you cross multiply, 2n is equal to 5 times 25, and 5 times 25 is equal to 125. Then n, we would divide by 2, and 125 divided by 2 gives us 62.5 kilometers. So if my drawing has Carville to Danville, this measures out to be 5 centimeters, then the actual distance is 62.5. If you think about it, here, 2 centimeters, approximately right there, that's 25 kilometers. And then approximately another 2 centimeters here, that's 25 kilometers also. So I have 25 plus 25, and then we have half a centimeter here, and that's going to be 12.5. So that's how we got 25 plus 25 plus 12.5, 62.5 kilometers. Hopefully that won't confuse you guys too, what I just did here with the 25 plus 25 plus 12.5. But I'm just showing you the 2 centimeters gives us 25 kilometers. But follow the proportions instead. Make sure you follow the proportions, and then you can cross multiply and solve for the actual distance. Let's take a look at a couple of examples here. Find the distance between towns with the given map distance. Use the scale. So here's our scale. Let's say we have 1 centimeter is equal to 15 kilometers. Then how much is 3 centimeters equal to? Basically, you're going to multiply 3 centimeters times 15 kilometers, because every centimeter is going to be 15 kilometers. And you're going to have 15 kilometers 3 times, so all you have to do is just multiply 3 times 15, and we get 45 kilometers. The next one here, 5.2 centimeters. If we have 5.2 centimeters, each centimeter is equal to 15 kilometers. When you multiply that together, you should get 78 kilometers. Our last one here, 12.7 centimeters. At 12.7 centimeters, and each centimeter is 15 kilometers, you're going to, again, multiply the 2, and you end up with a 190.5 kilometers.